All right, honors. So what we're going to begin doing right now is actually some video solutions to the homework that I assigned last time. Now, I had actually briefly, very briefly, covered the three equations we use in class that have to do with acceleration. So there's this one, and this one. This bottom equation we actually came up using Arbel rolled down an inclined plane, and we actually came up with the linear equation, which is that we have a line that looks like this, and that represents the velocity of the battery as a function of time. And we have u here as the initial velocity. And so as the battery rolls down the hill, it gains more and more speed, and we realized that that was a linear graph. And so the equation of the line, the y equals mx plus b equation, turns into v equals at plus u. The other thing that we remember is that the displacement is in fact given as the area under this graph. And so when we get the area under this graph, that actually gives us this equation here when we use our formulas from geometry. We're not going to prove that in class. Instead, what we're going to do today in this homework is simply label what each variable means, and we're simply going to be using the acceleration equations to calculate certain quantities. So we have s as the displacement, and you're going to see that this gets used interchangeably with distance. We have u, which is the initial velocity, or the starting velocity. We have v, which is the final velocity. We have a, which is the acceleration. And we're going to have t, which is the time that passes. Now, what I'm going to give you today basically is a procedure for solving these problems. Now, I want you to notice something. I'm using notation that is used in the IB program, and I wanted to get you used to this in case some of you decide to continue on that route in a couple of years. You will be taking at least one science class, and the way it works in IB is we don't write meters per second for velocity. It's almost like what we're saying is meters per second is meters times 1 over seconds, and 1 over seconds can be written as seconds to the negative 1. So it doesn't mean anything in real life. It's just a way of doing the typography. I guess it's cheaper or something to do it that way. I don't know, but this is how they do it in Europe. And IB actually follows European naming conventions. So these equations, by the way, we kind of abbreviate them as the SUVAT equations. It's just the letters kind of turned into an acronym, and it just means that we're going to be using our kinematics or motion equations. So SUVAT is the abbreviation we use. So whenever I use the word SUVAT in class, that's what we're doing. So for number one, what we're going to do is we just read the initial velocity of a car is 2 meters per second, becomes 8 meters per second after traveling 2 seconds under constant acceleration, and we want to find that acceleration. So what we're going to do is I'm just going to actually write out the letters of SUVAT here. And I'm going to do this for every problem. So the first step in any of these problems is you actually write out the letters. Now, I don't know what its displacement is at the end. I know that the initial velocity is 2 meters per second. I know the final velocity is 8 meters per second. I don't know the acceleration, but I do know it travels for 2 seconds. And now what I'm going to do is I'm simply going to bring down one of these equations and use it to solve. So since I want the acceleration, let me pick the easiest looking equation that has acceleration in it, which is the bottom one. So now what I'll do is I'll actually write the equation down as v equals at plus u. And now I can put in my numbers and I can simply solve for the missing quantity. So I have 8 equals my unknown a times my time, which is 2 seconds, plus the u, my initial velocity, which is 2. I'll subtract 2 from both sides, and I actually end up getting that 6 equals 2 times a. And when I solve, that's going to give me that a equals 3 meters per second squared. So that's how I get the acceleration. Now, for number 2, I'm going to do a similar process. It says a car accelerates from rest to 28 meters per second in 9 seconds. Find the distance it travels. You notice that S is the letter for displacement, but in one-dimensional motion, distance and displacement overlap, and we saw that in the last homework that we did. There's really not a big mystery here. The process is simple. We're going to write out SUVAT. We're going to write out SUVAT. And we're just going to write what we have and what we don't have. So one small hint, whenever you see the word from rest, that's your clue that U is 0 meters per second. So that's 0. V is 28. My time is 9 seconds. And this is seconds. My acceleration is unknown, and I want to know the distance that it travels. So, one thing here. First, let's get the acceleration. That's not directly helpful, but let's get it anyway. So I'm going to use V equals AT plus U. And then I can put in some numbers. So I know that 28, equals A times 9 plus 0. And so 28 over 9 is going to be my A. I'm going to take that out to 2 decimal places. So 28 divided by 9, when I actually work that out, it's going to give me 3.1 meters per second. Meters per second squared. And now we can get the distance. So finally, we can use S equals 1/2 AT squared plus U times T. So that's going to be S equals 1/2 times 3.1 times 9 squared plus 0 times 9. So this will actually just work out to be 0. So S is going to end up being about 1.6 times 81. We'll actually calculate that out. And that's going to give us about 125 or 126 meters when we're done. So that's problem number 2. What I'd like you to try to do, so one thing, it says brought to rest. That means V equals 0. U equals 12. S equals 45. I want you to find A. So try to use this formula to get the answer. And I want you to actually write out SUVAT and label these. And then what I'm going to have you do for number 4 and 5 is something very similar. So what I'm going to have you do is I'm going to have you do questions 1 through 5 for homework. And we're going to take a look at 6 and 7 in class together. So just to review, do 1 through 5 for homework. And we're going to work on 6 and 7 in class. All right, so that should get us started. I'm going to publish this video, and let me know if you have any questions when you get to class tomorrow.